Welcome back, physics fans, and we're working on the fifth and last lesson of work, power, energy of Physics 11. And just a quick recap, we've covered that work is force times distance, and the distance vector and the force vector have to be in the same direction. And if they are, then that's positive work, and if they're in the opposite, then it's negative, and if they are perpendicular, then it's zero work. The work energy theorem means that whenever there is energy, you have the ability to do work, and whenever there was work done, it changed the energy. So it just goes back and forth. An object lifted a height has what's called gravitational potential energy. We write down it as mgh. Energy stored in something that's moving is called kinetic energy, and that's 1/2 mv squared. That the conservation of energy is that it's conserved, that the total energy is constant. So when we add up for mechanical, the potential energy plus the kinetic energy at position A, that would also be what the potential and kinetic must equal in position B. We're talking about heat energy now and thermal energy. Heat, like in a form of a cup of hot coffee, will always go from a hot source to a cooler source. Unlike work is done in your refrigerator, okay, unless work is done in your refrigerator. So yeah, there's work done and it'll cool it down. Another note is that there's no such thing as something being cold. A cold object just has less heat. Okay, so it's just the amount of heat, okay, compared to its surroundings. If it's less than its surroundings, you call it cold, and if it is more than its surroundings, you call it hot. Heat energy is a form of energy which transfers among particles in a substance, okay, and that's by means of kinetic energy, the motion of these particles, and it's under the kinetic theory, and the heat is transferred by particles bouncing off of one another. As a form of energy, the units for heat is, again, in joules, it's energy, though heat is also measured in different units. One is calories, okay, and a calorie is defined as the amount of heat required to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. How specific is that? There's other ones, like the British Thermal Unit, or BTUs, is a measurement of energy, but it's just a different unit. So let's just get to the nuts and bolts here. Heat energy is often confused with temperature. To understand the difference in physics, we'll introduce this formula. There is temperature, and it does have something to do with the energy, but also matters on how much you have of the product, the mass, and this constant, which is called specific heat capacity. The specific heat capacity is a constant. It's kind of like mu is a constant for two different materials in friction. C is a constant for the material that you're heating up. And it basically says how many joules of energy it'll require 1 kilogram of that to increase in 1 degree Celsius. Now, 1 degree Celsius is the same as 1 degree Kelvin as well. Just understand that Kelvin and Celsius are just offset by 273, I think. So it can be the same. And water here, we have a listing of the specific heat capacities. Water holds a whole lot of energy. Okay, it can contain a lot of energy, but some metals don't hold a lot of energy. Okay, it doesn't take much energy to heat them up, but it takes a lot of energy to heat up water. Okay, so delta T is the change in temperature, and that gives us the change in energy. Now remember, when we talked about what is the potential energy of something, and your answer is with respect to what? Okay, because you always need to measure the potential energy with respect to the 0 point. Well, same thing. How much heat energy does it have an object has? That's not what's important. What's important is how much the change in the heat energy is. How much is the change in the temperature that makes the change in the heat? Okay, so the temperature final minus the temperature initial. Let's get right to the questions right away. How much heat does it take to raise the temperature of 100 grams of lead from 20 degrees Celsius to 33 degrees Celsius? Okay, the energy, okay, the heat energy is equal to mc change in temperature. The mass is 0.1 kg. The specific heat capacity of lead is 130. And if you wanted to put the units in, it's joules per degree Celsius per kilogram as well. And then the change in temperature is 23 and it's positive. No, it's 13 and it's positive. So positive 13 is the change in the temperature. So when we multiply those numbers together, we get 0.1 times 130 times 13, and we get 169. So it takes 169 joules of energy to raise the temperature of 100 grams of lead from 20 to 33 degrees Celsius. Okay. Number 2, how much heat energy does it take to raise the temperature of 10 kilograms of water from 5 degrees Celsius to 95 degrees Celsius? So about 5 degrees Celsius is just coming out of the fridge, right? It's pretty cold. Fridge is around 4 and stuff like that, maybe 3 degrees Celsius. And 95 degrees Celsius is close to boiling. So you're going to take 10 kilograms of water, which is about 10 liters, and you're going to raise the temperature of it from 5 to 95. How much energy does that take? Same formula, and the mass is 10. The specific heat capacity of that is 4,200 of water, and that goes up 90 degrees. Okay, and so Mr. Calculator will do 900 times 4,200, and that gives us 3,780,000 joules. Or we can go 3.78 megajoules. Okay, the other ones just go on just as easy as that. How much heat does it lose? So it's losing temperature here. So the change in temperature is negative 30. Here is, now we're given the energy and you have to give the mass and find out what its final temperature will be, or the raise in temperature. Okay, and then there's absorbs. What is the specific heat capacity of this substance? It's basically, again, just using the formula. So try out those. It has those answers. And there's the answer for number 5. Okay, then if you want to challenge, number 6. 500 grams of copper at 50 degrees Celsius is dropped into a bucket of 2 kilograms of water that's at 20 degrees Celsius. What will be the temperature of the system as it stabilizes? Hint, the final temperature of the water and the final temperature of the copper are the same. And that's the temperature that you have to find out. So the energy lost by the copper equals the energy gained by the water. Okay. Thank you very much. Subscribe. Leave lots of comments down below. Smash that like button 42,000 times.